Okay, so now we've got all of these variances. And the first step, since they have equal ends, this is we simply get their average. And what's their average? Their average is their sum divided by what? By the number of groups, by 4. So it would be 1. So s squared within equals 1 plus 1.3 plus 3 plus 2.34 divided by 4. You've got four values, and you average them, so you just add them together. And you divide by the number of values you have, or number of scores you have. And that gives us a 7.64 divided by 4 gives us 1.91. So s squared within is 1.91. Excellent. So now we get to a little bit of a different aspect of this. 1.91. Now we need to calculate s squared within. And s squared within, conceptually, is what? Between. We need to calculate s squared between. What is s squared between, conceptually? So let me point out to you what s squared within conceptually is. Conceptually, s squared within is the variance within each of these groups averaged together. So you take this guy, and you take the value of the variance, the spread. You take this guy, and you take the value of the spread. You take this guy, and take the value of the spread. This guy, and the value of the spread. And you average them, getting an average of the variances of these groups. Now, s squared between is that. It's the value of the variances here. It's the same thing. In addition to the effect, the spread of the means from each other. How far are the means from each other? So it takes into account two things. It takes into account the within. So there is a component of s squared between that is actually the within. But there is an extra component, which is this extra spread in the means. If the means are spread from each other, that's the extra thing. If the means are exactly the same, then that will be 0, and s squared within will be equal to s squared between. Everybody understand? This is a very important concept. Yes, Austin.
S squared between is the difference between the different means in each group?
S squared between is the difference between the means plus s squared within. So it has these two components. It's how spread the means are from each other plus the variance within each group. OK? How many get that? How many? Raise your hand. OK. Some people are still having trouble with it. Let's talk it out if it's difficult. So think about this as being a s squared between as being a combination of two factors. It's a combination of the fact that you have a variance within each group, and that's your s squared within, plus the fact that when the means start to differ from each other, they spread apart, creating even more variance in the s squared between. So s squared between is what type of variance? Is it the variance that is sensitive to the differences between means or insensitive? How many say it's sensitive? How many say it's insensitive? Very good. Excellent. So it is the variance that is sensitive to differences between means, meaning that if the means start to show differences, the value of s squared between will start to become bigger and bigger than s squared within.
I'm sorry, but why would it be sensitive?
Why would it be sensitive? It's the way the Fisher developed the calculation of the s squared within. S squared between. He calculated this variance by taking into consideration the means. Okay, so you will see it. I mean, that question is a perfect segue to this point. So to calculate s squared between, you don't do this process of just calculating the within variance and then just averaging them. You actually take each of these means. Okay, you see each of these means? So whenever you're doing this on the test, circle your means. Circle the means. So you take each of these means. You've got 4 means now. And what you do with them is something very interesting. You basically treat them as if now they are your, so I'm going to erase this since we really don't need it. And what you're going to do with them is you're going to treat them as if they are your your sample. So you're going to actually treat them like this. You're going to take each one of them, and you will treat it as if it is a score in your sample. Okay, you see what we've done? We've taken the means, and we are now treating them as if it is a score in a sample. And what we're going to find here is something called the grand mean, like the mean of means. We're going to calculate the mean of these means. So what is the mean of this mean? This is not very different from what you've done in the past. You just basically are now calculating something from, so 11 plus 6.7 plus 5 plus 14.3 gives us 37. So it's 37, the sum of these, divided by 4. And that gives us 9.25. Now what we do is exactly what we've done every time. We basically now calculate the variance of this set of scores. We actually calculate the variance of this set of scores. To calculate the variance is what you've done forever and ever. You basically say x minus m, so 11 minus 9.5 gives us 1.75. Then 6.7 minus 9.25 gives us minus 2.55. Five minus 9.25 gives us minus 4.25, and then 14.3 minus 9.25 gives us 5.05. And this should sum up to 0, does it? Yes, approximately 0. And now we square these guys. This is 25.5. This is 4.25 times 4.25 gives us 18. And this 18.1. And then 2.55 times 2.55 gives us 6.50. I know I switched the decimals, but it doesn't really make a huge difference. I'm going with 2 now. And this is 3.06. Okay, so now this is x minus m squared. You sum it up, giving you the s squared. Let me calculate that. Plus 6.5 plus 18.1 plus 25.5 gives us 53.2 divided by degrees of freedom again. What's the degrees of freedom here? 3. Four scores, so degrees of freedom is 3. And that's 17.7. Did everybody get that? Yeah, everybody got that? So the question is, what is this s squared? What is this variance? And here it gets really confusing and a little bit intricate. This variance is actually the variance of the sampling distribution. This is a funny thing. In the past, we would calculate the sampling distribution by taking the mean, the variance of a sample, and we go and calculate the variance of the original population, right? Then we would, from the original population, calculate the sampling distribution variance. So this would be, for example, pop SDM, right? Or SM, S squared M. This would be pop SD squared, or S squared, right? Now, what we've done here is actually we calculated this indirectly. We actually calculate this by doing this process of seeing how different are each of these scores from the mean of the population. Because the mean of the and this is a little bit extra. You don't have to know it fully to fully be able to pass your test. But I'll explain it to you, and it's explained. It's explained in the book, although it's hard to understand, but I'll help you with it. You can see on page, if you can open page 319. Open to page 319 for a second. Okay, if you open to page 319 on figure 10.2, if you look at this, these are original population original populations, and original populations. Now, let me ask you this: what is a sampling distribution? Remember that demo I showed you, and I said, please play with it, it'll help you. What is a sampling distribution? Can you give me in a nutshell what you physically do, what you mathematically do to calculate a sampling distribution? Yes?
Like, however many numbers you specify, and take random numbers out of the distribution.
Very good.
And then average them.
Excellent. Very good. Okay. So basically, you have a distribution, a big distribution made out of original scores. And if your sample is 5, you take 5 of these scores, you average them, and you get a sample, and you plot it into a distribution. And you keep doing that over and over again. Please focus with me. This is a very important point, very difficult point to grasp. So I want you to leave everything and just focus with me for about 3 minutes, I promise. So when we calculated the sampling distribution, we had an original distribution, original population, and we took samples from that population. We took samples, let's say, of 5, pulled them out, and then we plotted them here, and we kept doing it. So I pulled 5 of these. These 5 then gave us a mean, and I plotted it here. I did this over and over again until I produced another distribution called the sampling distribution of the means. Now look what you're doing here. What you're doing here is you're treating each mean as a sample. So you're actually doing exactly the process we are talking about. You are taking a sample. Here are several means. You created a sample from them, okay, a mean, and you plotted it here. And you did this you took these means, you took the mean of these means, which is exactly like this process. You need to stop it?